A joint presentation. I'll read out the bios one by one. Anil Bhise, Senior Manager, Product Marketing, Mitsubishi Electric India. He is currently working with the Factory Automation and Industrial Division of Mitsubishi Electric and is responsible for modular control systems and their allied software solutions. He is also working on projects that involve the implementation of data capture and processing systems, for example, to feed MES and IoT business systems. His considerable knowledge of manufacturing processes allows him to design appropriate control systems for different industry verticals, such as automotive, power, water, and infrastructure sectors. The second speaker is Vineet Nayyar, Cluster Leader for Industrial Sector for North and East India and leads electronics industry for IBM India. He has over 22 years of experience in electronics, retail, consumer products, wholesale, and industrial product sectors. He has covered roles that span industry business operations to IT and management consulting. He has also led international teams working with leading organizations across different geographies: India, APAC, USA. Vineet is a full-time member of the National Committee of ICTE, set up under CII to promote the Make in India for electronics. Please welcome both speakers on the stage.
Yeah. Good afternoon, everyone. Yeah. So a lot of thoughts has been shared from the morning for the digital enterprises. So let me put up our version of it. Okay. So before that, just an introduction of the company. Like, we belongs to the Mitsubishi. Mitsubishi is a global manufacturer of the different equipments for the customers for the industrial use. Okay, we make some kind of product like from escalators to the satellite designing to the lab centers and many more. Okay, with a start with a 1920, we are manufacturing with some kind of motors and fan for the consumers. Last year at the end of the March, we could able to have some kind of a more than 4,000 billion yen net sale of the product, okay, which comes to be near about 37 billion USD. Okay, and the industrial part in that is near about 27% of that business. Okay, so with that, I'm Anil Bhise. The explanation is already given, working with the Factory Automation Division of a Mitsubishi. Okay, with our mission statement, that changes for the better, that we generally live up with in our day-to-day life. Okay, so coming with that, last year we are presented some kind of story about the CMS system, condition monitoring systems. So let me recap those things. So many of us at the manufacturing unit might have experienced this, without knowing it, but then you might have experienced it. That some assets goes faulty without even knowing those things. Okay, so then when the asset is faulty, everything goes in a mess. But then what will happen before that? So let me start with the future actions and then we'll travel to the time on a backward. So just before that, there could be some kind of a clue, which is a smoke coming from the machines. But then that is a very few seconds before, that is too late to take any actions on that. Before that, there could be some of them, you may have experienced that there is some kind of a warm sensations of that particular equipment machines. Okay, and that could be happen before few days of the machines, which is running on that. If you go beyond that or before that, someone might notice that there is some kind of a vibrations, unusual vibrations, or the noise is coming from the machine. Some might be the bearing, might be the cranking, something is going wrong, and that goes for the couple of weeks. And overall, these kind of a noise goes increasing day by day. Before that, one might have seen some kind of unusual vibrations coming out that machine, and that will happen before few months. Okay, so when we are talking about those equipments, those are the few times where the machine was working, was very new. Okay, and we'll be giving a full kind of productions. But then, this is the time, real culprit of the time is that moment. We should able to analyze. So for that, last year we are talk about the FAC, that is a FAC sensors, vibration sensors, which can give some kind of alarm at that particular moment, where you can have some kind of a time for the planning for the maintenance, planning to order some kind of equipments which has got the long lead time. So we can plan those things in advance. Okay, but then story doesn't end over here. There is a loss in the factory because of the shutdown of machine, but then what will happen? What will happen to the previous machines to that? What will happen to the next machine? It will continuously demanding those parts from the earlier machine, but then earlier machine is down. How it can be delivered? What will be its effect on the resources? There are so many resources we already planned, the manpower, the raw material, which all on stake. So what will happen to that? There are different kind of commitments given to the customer based on the delivery, and there could be some financial influence of that. So these all are under the soup because of the failure of one particular machine. So what is that? That is what we talk about, say, when we talk about, say, some kind of a pre-alarming kind of conditions, the CMS solutions. This is the one we talk. So when we talk about the old saying, like rubbish in is equal to rubbish out. So that is what we mean to say. In order to make decision or in order to take action on that, we need to have the three things with us. The first thing, definitely, we need to have the modern or the framework in which we could be able to take some kind of a decisions. Second thing, the relevant data. Okay, irrelevant data will be just able to fill up the hard disk and not use of that. But then somebody has to work on that, some expert has to work on that to take the intelligent data or the meaningful data from that and then start working on that. Okay. The third one is basically timely data, timely and the quality data. These things are needed for such kind of system. Okay. You can see these images of the drink, and the human are very, we can say, good in analyzing and make the decisions. Without knowing many of the things, we generally take the decisions, and most of the time it's our correct decisions. But then look at this drink, it looks very simple, a child's play, but then when somebody wants to have these kind of a drink, it will go to the many factors, like one wants to have a drink, but then how he wants to have. There are many internal factors to that. The drinks could be hot or cold, should be served in a cup or mug or anything. This is okay for the human, he can take an immediate decision on that. But if we are thinking from the machine point of view, if you are thinking from the machine point of view, there are many factors. There are many external factors which are influencing that particular decision. If machine has to take a decision on that, it may have some kind of a weather conditions, whether it is hot or cold, depending on the decision can be taken. There could be some kind of a health related decisions, like somebody has to have the more sugar or less sugar kind of thing. Okay. If you are somebody selecting the tea, it could be hot or cold, or it could be a green tea or black tea, depending on the time on which we are trying to take the decisions. So these are the different permutations, combinations for the machines on which the decision has to be taken. But human are okay, customers are okay with that. When we are trying to relate those things with the current environment or the machines or the specific assets in the industry, humans are okay, they can take the decisions. Customers are also basically is having that kind of a knowledge, power that, okay, we need to have that kind of drink with this kind of a, say, mug size, how you want to drink it, okay? But for the machine, it is very difficult. Typically, if you talk about the local control systems, which is there in a machine, so this is too much permutations, combinations for the local controller to take care of that. So that is why we feel that there is a need for some kind of a edge computing layer in between that to take those kind of a decisions. Okay. So if we are thinking on that basis, the local controller will be having those kind of a decisions, but then above that, we'll be having some kind of a intelligent cloud services. Intelligent cloud services, which has to be installed and which could have some kind of a intelligent power to take a decision on that. Okay, there are many missing threads. We talk about the FAG sensors. We talk about those kind of sensors where the one sensor is installed for, say, taking the vibration sensing from that particular bearing. Both has got the very minimal cost in terms of the typical asset. But many of the times, if that particular sensor fails, what will happen to that? Okay, that there is a direct impact on the basically the production side. So immediate production, future production in stack. If he is a basically important asset, then what is the maintenance of that particular asset? So there are lot many time frames required, budgeting is required for that. It will impact my future orders also. Okay, so these are the some kind of a missing threads. So we need some kind of a software, some kind of a edge computing layer, which could link those kind of a missing threads. Okay, that is what we talk about the edge computing. That is what we required, some kind of analyzing tools which can reside in the cloud services and can have those kind of decisions. So with this point, I will like to Vineet take it further for the analyzing tab.
Good afternoon, everyone. Just a quick show of hands. How many of us are from core manufacturing or related with manufacturing? Okay, sizable. And how many are from IT services providers? I think distribution is 50-50. Okay, good. So, I'll take about next 15 minutes of yours, and I'll try and cover demystify digitization in specific to industrial. Well, digitization has different meanings for different people. My intent would be, where are we in India, specific to manufacturing, specific to industrial area? Where is technology leading global manufacturers and global leaders? So what is on the plate for us to absorb? And third, how do we get there? Now, given the time, I may skip some slides. I have about 10 odd slides. So I'll take that decision on the fly. Sure, okay. So when I normally go to our clients, my first visit is always to the manufacturing plant to get a visibility and feel of how they operate. And post that, when I get into the conference room, meeting rooms with them, my question starts from, what is your current automation level? So for you to start your transformation, you need to have some starting point. So a couple of weeks back, I went to one of the state government cities, and a very large manufacturing organization wanted to know about digital, wanted to start digital, have allocated some small fund to do some pilots. When I dwelled deeper into it, they had not even enabled their factories on ERP. So for them, digital is, starting point is at least enable your manufacturing line on a ERP. So if you look at it, what is your starting point is the most important. Who are your key stakeholders? Are your key stakeholders on the shop floor? Are they ready to take decisions? Have you provided them enough decision-making ability and the data so that they can take decisions on the fly? Is that happening or not? It all depends upon what is your current maturity model? Where are you currently sitting? And that is where I want to start off. So when I look at the way industry is structured, we categorize that into 4 layers. So one is descriptive. Descriptive is what happened. So something has happened, and I want to know what has happened. So my machine has broken, it's gone down, it's unexpected downtime, heavy loss to me. I don't know why. I pull up all the reports. I'm trying to explore what's happening. Second level is I try to do predictive to some extent. So what ifs. So few of the ERPs, few of the systems, analytic systems also give those what ifs in a limited manner. I try to do that. Some of our Indian organizations are also in this space, trying to mature somewhere, trying to do that. Next stage is, I've done what if. I know that my machine has a propensity to fail after a point in time. That is the information I have. Then what? Do I have a prescription? Prescription, you go to doctor and he prescribes you medicine, right? He prescribes you medicine for a fault. Do you know the fault? And hence, do you know how to address that fault? So that's a prescription. Maybe 1 or 2 automobile organizations are in this space. And then we have a niche space which is emerging very fast called cognitive. So cognitive is nothing but you take prescriptive in a different level, wherein you bring in all different kinds of unstructured data. So unstructured, when I say unstructured data, it could be natural language. The way I'm talking to you, I talk to machine. The weather data, your logs, SQC charts, anything which is unstructured, I bring them all together and build algorithms and support the prescription and come back in a more intelligent prescription. So that's cognitive. To give you a semblance of what cognitive can lead to all of us. Heard of automobile which is put in commercial use called Ollie? It's a self-driven vehicles. You go to Miami, go to New York, you can hop on to next time Las Vegas. Next time go there, hop on to that. They're self-driven vehicles, no driver. So what that means is there's some sensors, some control panels, some limited edge computing which is working, which is sensing, which is seeing, reflecting, hearing, all sensory devices. So which knows about your environment, and on the fly they are able to take decisions. Other companies, so look at connected cars, what is happening around the world, something similar. Look at organizations like Cemex, they're one of the largest cement manufacturers in Mexico, how they have transformed themselves. Look at from a consumer side, look at whirlpools, Kone elevators. So nowadays, you have ability for your refrigerator to invoice for a milk if your milk is getting depleted. So they can do a visual check on what is getting out of stock. You like veggies is out of stock, they can order for you. So all that has started to happen in either a limited way or in a commercial way. But that's where industry is heading. So that's how cognitive sooner or later would be able to hit us. Now, given there are these four paradigms, and I've introduced to the cognitive, I'll quickly jump onto a few slides. How does it all work? So instead of saying why it is important, I'll focus my time next 5-6 minutes on how. So how does it work? So very simple. You start by gathering data. How do you get the data? You put some sensors, you put a controlling panel, and you will have a communication layer. It'll give you back some IoT data or edge computing or a cloud layer would be able to absorb the data, compute it, process it, analyze it, give back to you. So there has to be a basic fundamental layer. So you start that experiment. Then what? You have data, then what? Once you have a data, you obviously build algorithms, you make it more meaningful. So you make those charts and try and understand those data. Try and build applications around that, whatever you have built. So if you have data for X, Y reasons, build applications on that environment. In IBM case, it is Blue Mix environment. So build those applications so that you can use that data. And then present the data to the shop floor people who actually take decisions. So that data should ideally store near to you, near to the shop floor, which is why edge computing is important as shared by him. Third is, you have done some basic data analytics, you get onto the more complex algorithms, define more complex problems, and build your analytics around it. And the last being infuse cognitive. So bring all the unstructured information. So in industrial automation parlance, bring all your SQCs, bring all your traditional log charts. So, you have history of in shop floor maintenance records. When was any asset brought into your production line? We know that. What is the life of an asset? We know that. Bring all that into a cognitive layer, and your cognitive layer will be able to tell you what is the balanced life of that specific asset, when it can go wrong, what is the maintenance required, so that you don't need to overspend or underspend. You know precisely where do you need to spend. So these are the 4 simple steps. All the use case going forward, all the use case going forward are based on these 4 steps. Largely cognitive or analytics, when you look at in industrial, are staggered in these 3 pillars. So one is you want, what is objective, and what is business driver, benefit driver that you want to drive. There are 3. One is you want to have your assets perform well. You don't want downtimes, because downtime means, unplanned downtime means cascading effects, both in the front line supply chain and your back line. So you don't want downtimes. That is first objective, performance of your assets. Second objective is performance of your quality parameters and warranty parameters. How do you use analytics and cognitive in driving that? And third is, how do you use your resources? Can you use technology and cognitive to ensure that your resources, may it be human resource, may it be energy resource, can that be taken care of? Can that be optimized? So these are the primary, when you go in market, mature market, all our examples are related to one of these 3, starting from the first one, because the benefits are more in the first one. And I have one slide each for each one of them. Maybe I'll quickly wrap them up given the time constraint that we have. So how it works is, when you have built your ecosystem, so in this case we have put in asset as a motor. So you have motor, you put in various kind of sensors there. You capture those through control panels, you have connectivity, you get all the communication, you put it IoT layer around it, you do analytics, and you build in a controlled environment, you build algorithms. How would my, in ideal situation, motor work? I know the charts, I know the algorithm, in a controlled environment. Then comes the real environment. And when you start simulating it, your charts at certain point in time would start showing some kind of aberrations or deviations. That is the point for when you understand that there is a need for you to look at your asset. What is the descriptive and prescriptive reasons why those aberrations are coming? So at a high level, that's primarily a logic of preventive maintenance using cognitive. So you can capture data and you can put that to use. Now, if I have to underneath peel the technology at this point in time, it needs a lot of applications. It needs hardware, sensors, it needs control panels, it needs cloud layer, it needs analytics layer, it needs, obviously, and cloud has to have your storage, computing, processing, all that stuff. And it also needs an asset management layer. So all that has to come together, and which is one of the reasons we chose that we should partner with other organizations to successfully deliver. No one organization across the world can claim to say, I can do digital end-to-end. It's all about right collaboration for a given use case. Next use case is visual inspection. So think how we used to do, and I'm basically a textiles engineer. In our days, about 2 decades back, when I was on the shop floor, there used to be a visual inspection, and till today, there happens to be visual inspection, plus over and above, there's an infrared inspection. That's a level of inspection which happens. That is outdated in market now. The way market is moving is, we use robotics to inspect. So cognitive have built analytics in terms of what are the algorithms, how should my visual impression have, and in case there's a deviation to it, they flash it out. And then once we find a deviation, there's another cognitive layer which addresses and prescribes you the prevention of that. So the quality is driven by robotics, not by visual recognition. So without getting into detail, because I don't have time for this, the basic premise is it's a looped environment. So you build algorithms, and you have libraries of information which calls out specific defect. As and when you find additional defect, that defect adds to the existing library. So you keep on building, you keep on learning how to call out defects. And all that you start feeding back into your robots, and which does your actual visual quality inspection. Very quickly on how do you manage human safety. We have started putting, ourselves, we have various variables. So I put one band, my kids also put one band, right? So likewise, we have variables for industrials also. So we have work in hazardous situation, we have chemical plants, we have temperature controlled zones. So how do you control safety and ensure safety of your human resource? And not only tell them, but tell the supervisors, so that all the alerts are generated and executed to avoid any mishaps. All that can be done centrally, globally, from a single location, even if your plants are spread out. So last two slides, just to summarize on cognitive. So practically, think of this like you have a human brain. What Anil said, you have to take complex decisions, so many permutation combinations, you need to have something. What something is, bring that analytics closer to your shop floor. That closer is your edge computing. That far away storage, far away computing is your cloud computing. So do all that and bring your closeness of computing to your shop floor. And doing that, you can take all real-time decisions, be it your predictive manufacturing, maintenance, quality control, or your energy, or your human resource management. So all that is happening today. I'll not get into details of the benefits. If interested, you can get on to IBM.com. The intention of this forum is not to sell an offering. So get into those and see what are the benefits or the real benefits which have been accrued. One last slide. How do you start? So I started my 15 minutes from that side. How do you start? You start from your own matured, where you're currently matured, right? You identify that. This is a very complex slide. The whole purpose of putting this slide is there's so much to do, but you have to pick one thing. Your budgets are very limited. What do you pick that? See where you are. If you need to do a simple tally, do that. If you need to implement a simple ERP, do that. If you need to augment and enhance your business processes through ERP, ideally you should do that. Once you have business stable processes, that is the time for you to look at automation. Because at least your base function is done. At least you have BOM, MRP. You know if I capture automation, I can then influence my supply chain. Because just capturing data, trying to do a pilot means nothing. It's a waste of your time, your money. So understand where you are and then pick up a right use case based on that. Thanks a lot, gentlemen. I'll hand over back to Anil.
Thank you, Vineet. Looks like a dream on that. But no, these are based on the few engineering facts, okay? We need to have just kind of one kind of an open platform so that these kind of some software, some hardwares can be installed on that. There is no need to revamp entire production plant or the hardware or the software you have. We need to have those kind of assets also in that, okay? So in an asset, when we talk about asset, we have so many assets in the existing plant. There are many brownfield plants which one needs to have some kind of modifications, but then assets are little bit old. What we need to do is basically try to connect those things to a simple central systems or the smart systems and try to get the true value from those kind of existing asset. Okay. By saying that, try to connect those assets to the smart system is very easy by standing over here, because I am not sitting in front of, say, 500-ton press machine, which is near about, say, 30 years old, without some kind of a modern controller or a communications on that. Also, I'm not sitting in front of, say, a molding machines, which is 30 years back and has some kind of communication protocol, which I don't know how to communicate or how to read it in my modern systems. So we have so many legacy systems installed on the shop floors, and something look like it is some kind of a lock is there when we are trying to get some kind of information through it. So how to go ahead on that? So somebody needs to have, or we needs to have some kind of a key which can enable us to connect those assets, existing asset, and try to get the data. Okay, there could be a multiple vendors, okay, from which the devices or networks are there, from which we need to fetch the data. There are few legacy systems from which we need to fetch the data. Okay, diversifying IT softwares, diversifying data storage formats are there. Okay, so area of the cloud environment. So all for this connecting those things, we need to have some kind of key. Okay, so the key could like some kind of some platform or edge computing platform which resides on the shop floor environment, and does the work for you. Something the sensor is connected to that. Okay, so data will be available on that. This is some kind of an open platform which will have some kind of collectors to collect the information from these different systems. Okay, it will have some kind of storage capability, a data processing capability. Okay, some softwares also installed on that. Some processes are there. So this is some kind of a, say, open IT platform which we need to have. And then further, we can have a cloud connectivity and ERP or MES systems running top of that. So that is from my side. Okay, so thanks for the listening for us, and thanks IBM and ARC for arranging such an event.